In 1916, a British engineer dared to build a weapon that even his own army tried to ban. It wasn't elegant, it wasn't precise, but it worked. William Howard Livens was told his design was too crude, too dangerous, and too unpredictable. Months later, his invention would drown entire enemy trenches in a single, silent wave. Livens was not a career soldier. He was a mechanical engineer who joined the Royal Engineers when the First World War began. On the Western Front, he saw firsthand what artillery could and couldn't do. The guns could level hills, yet they struggled to deliver one thing effectively: gas. Each shell carried only a tiny amount. To blanket a German trench, thousands were required. Livens believed he could do it faster, cheaper, and deadlier with plumbing pipes instead of artillery barrels. By early 1916, Livens began experimenting behind British lines near Wimereux in northern France. He welded sections of drain pipe into short launch tubes and packed them with a simple propellant. Into each tube, he loaded a steel drum containing phosgene gas, a chemical already notorious for its suffocating effect. Officers laughed when they saw the crude setup. Some called it a farmer's toy, but Livens insisted the principle was sound. If dozens or hundreds of these tubes were fired at once, they could release a massive cloud before the enemy even realized what was happening. When Livens finally tested the weapon, it worked. The gas drums flew in a flat arc and burst exactly where intended. The trial was witnessed by astonished engineers who reported that the device could project far more chemical agent than standard artillery. The next step was to scale it. Livens built new models with stronger steel and electric firing circuits so that entire batteries could fire simultaneously. He called it the Livens Projector. In April 1916, during a classified test, several dozen projectors were buried in the mud of the Western Front and wired to a single firing switch. When the signal came, they launched together. Hundreds of pounds of gas roaring across no man's land in seconds. The demonstration was devastatingly effective. The British Chemical Warfare Department took notice. Soon, thousands of Livens projectors were manufactured in Britain's factories. They were simple tubes, no moving parts, no recoil system, no aiming mechanism. Crews merely adjusted the angle and fired by electrical current. The entire system could be hidden underground until the moment of attack. By 1917, the British Army had quietly deployed the weapon in several operations. On the night before key offensives, engineers buried hundreds of tubes side by side, each loaded with gas drums and wired for synchronized firing. When triggered, the result was an instant wall of toxic fog. The Livens Projector changed chemical warfare from scattered shelling into industrial-scale saturation. It required almost no maintenance and could be mass-produced at low cost. The weapon's simplicity made it terrifyingly efficient, and that raised ethical alarms inside the British High Command. Gas warfare was already controversial, but Livens' design made it far easier to unleash on a massive scale. His name rarely appeared in reports. The army preferred to hide the identity of the man behind such a weapon. Still, the results were undeniable. By the time of the Battle of the Somme, the Livens Projector had become one of the most effective chemical delivery systems of the war. In the space of a single year, Livens transformed from an ignored engineer into one of the war's most influential inventors. His concept of massed, disposable launchers would later inspire post-war artillery, design, and even influence early flamethrower and smoke systems. Yet for all his success, Livens remained haunted by the implications of his own creation. The weapon had given Britain a brutal advantage, but it also blurred the line between engineering ingenuity and moral destruction. As 1917 approached, Livens prepared to test an even larger configuration, one that would fire thousands of projectors in a single coordinated strike. The world had seen gas before. It had never seen anything like this. By early 1917, William Howard Livens had earned the reluctant support of the British High Command. His weapon, once mocked as a plumber's experiment, was now being produced by the thousands in Britain's expanding munitions factories. Each steel tube was cut, welded, and inspected under secrecy before being shipped to the Western Front. What made the Livens Projector different from every other weapon in the war was its scale. It wasn't designed for small units or skirmishes. It was built for synchronized devastation. A single battery could deploy hundreds of launchers, wired together and buried beneath the mud. At the push of a button, hundreds of gas drums would ignite, forming a lethal curtain that stretched across the battlefield in seconds. The British called it instant saturation. To the soldiers in the trenches, it was something else entirely. Hell without warning. The first large-scale operational use came near Arras, in the spring of 1917. Livens's teams worked for nights under the cover of darkness, digging shallow pits and installing hundreds of tubes at preset angles. Each was connected to an electrical control panel hidden in a nearby dugout. The men who prepared the weapons wore improvised masks as they filled the gas drums. The fumes from even a tiny leak could kill within minutes. When the moment came, the order was simple: fire all projectors. In an instant, hundreds of gas drums arced over the no man's land and crashed into the German lines. Witnesses recalled that it looked like a strange mechanical storm, silent flashes followed by clouds rolling low and heavy over the earth. Within minutes, communication from the German trenches went dead. The effect was immediate and terrifying. For Livens, it was proof his weapon worked on a scale no one had imagined. For the men who witnessed the aftermath, it was a glimpse of the war's moral collapse. Word of the weapon spread quickly through Allied headquarters. Officers who once dismissed Livens now requested his projectors by the hundred. The French and American forces began studying the design for replication. Livens himself was promoted and given command over further development, including new types of chemical mixtures and incendiary fuels that could be delivered by the same launcher. By mid-1917, the Livens Projector had evolved beyond chemical warfare. Engineers began experimenting with oil-based incendiary mixtures, turning the device into a primitive flamethrower system. Instead of gas, the drums carried burning fuel that could coat enemy positions. When fired en masse, the explosions created firestorms that consumed bunkers, dugouts, and trenches. These operations were kept secret. The official communiques merely referred to them as gas projector barrages. Livens rarely appeared in person to witness them, but his invention was now integral to British strategy. The simplicity of the Livens Projector also made it expendable. Once fired, the tubes were abandoned. They required no recovery, no recoil system, and no maintenance. In an industrial war where logistics defined survival, this made Livens' creation priceless. 1,000 launchers could be built faster than one field gun, but the very efficiency that made it successful also made it horrifying. The devastation was indiscriminate. Livens' projector didn't aim, it saturated. Civilian villages caught in range were often gassed along with the enemy. Reports filtered back of empty towns, livestock suffocated in their fields, and soldiers refusing to approach captured positions for days afterward. Even some within the British command began to question whether Livens had gone too far. Yet by now the war had normalised mass destruction. Ethics was secondary to victory. In late 1917, Livens' team prepared for what would become the largest chemical strike of the war, an unprecedented test of synchronization. Thousands of projectors were lined up across several miles of front, wired into sections, tines, and timed by electric current. The plan was to unleash a single coordinated wave of gas and flame that would devastate every trench ahead of it. For weeks, engineers worked in secrecy. Rain turned the trenches into rivers of mud. Many of the tubes had to be reburied after collapsing. Yet Livens insisted on precision. Every launcher was mapped, every angle measured. The firing would last less than a minute, but its effects could alter the entire campaign. When the night came, Livens stood in a command post behind the lines as the operators connected the final cables. At exactly the scheduled time, a single electric current passed through the wires. Across the front, the earth erupted. Thousands of drums soared into the darkness, trailing smoke and sparks. They landed almost simultaneously, bursting into clouds of gas and pillars of flame. The ground trembled. The Livens projector had reached its full potential, and with it the full horror of what modern engineering could do. The aftermath of the mass Livens projector assault in 1917 shocked even seasoned officers. Reports from intelligence units described scenes of trenches silenced in minutes. Entire sectors of the German line had been overwhelmed before a single artillery barrage began. The attack had achieved exactly what Livens intended: maximum destruction in minimal time. But with its success came new scrutiny. Commanders recognized the strategic potential of such synchronized chemical strikes, yet many feared the political and moral backlash. Gas warfare was already condemned in the press. If the public learned that Britain's newest weapon had been designed for wholesale chemical release, it could cause outrage at home. Livens' name, therefore, was deliberately omitted from official accounts. The weapon was referred to only as a special projector apparatus, its inventor reduced to a line in a classified report. Livens himself, however, continued refining the design. By 1918, he had introduced better ignition mechanisms, larger drums, and a simplified electrical grid system. The newest models could be fired in waves, rows of projectors triggered in sequence to extend the duration of attack. These rolling barrages of gas and flame blurred the line between engineering and annihilation. In one of the largest coordinated strikes before the armistice, over 4,000 Livens projectors were deployed in a single night. The preparation took weeks, with teams working silently under tarpaulins and camouflage nets. Each section of tubes was wired to an independent control box, allowing officers to fire them in patterns. At 0 hour, the entire sector ignited in a storm of gas and heat. The German defences collapsed within minutes. Prisoners later described the terror of being caught inside trenches filled with invisible poison and burning oil. Many never even saw the source of the attack. To them, it seemed as though the earth itself had turned against them. For Livens, this was confirmation that simplicity could defeat sophistication. His projector, built from industrial pipe and scrap steel, had succeeded where complex artillery designs had failed. Yet, as reports of civilian contamination reached British intelligence, even Livens began to question what he had built. Letters from officers described abandoned villages, dead animals and men, collapsing without wounds. It was the mechanical perfection of mass death, efficient, silent, and faceless. In the final year of the war, Livens was reassigned to assist in the development of flame and smoke projectors, expanding his design for non-lethal purposes. These adaptations could create instant smoke screens or ignite oil fields, tactical tools that relied on the same principles without using poison. The hope was to preserve the innovation while removing the horror. But the war ended before these refinements could be tested widely. When the armistice was signed in November 1918, thousands of unused projectors lay buried in the mud of France and Belgium. They were never recovered. The steel rusted, the wiring corroded, and the gas drums sank into the ground. The weapon that had defined trench warfare was quietly erased from official memory. Livens returned to civilian life with little recognition. There were no medals, no public ceremonies. His invention had been too controversial to celebrate. For years, his name was absent from wartime histories, overshadowed by generals and politicians. Yet, even in peacetime, the influence of his ideas persisted. Military engineers studied the Livens Projector as a model for large-scale synchronized firing systems. The concept of electrically coordinated barrages would later evolve into modern rocket artillery, systems like the Katyusha and the V-1 launching ramps. The principle was the same: mass firepower through simple repetition. Livens himself shifted his focus to civilian projects. In the 1920s, he experimented with domestic devices, industrial cleaners, fuel systems, and water pumps, trying to repurpose wartime mechanics for peace. Few of his patents succeeded, but his understanding of fluid pressure and projectile dynamics influenced industrial engineering in subtle ways. Still, the moral weight of his wartime work never left him. Colleagues described him as quiet, distant, and reluctant to discuss the war. In interviews, he referred to the projector as an unfortunate necessity. As the decades passed, Livens' name slowly faded from public awareness. But in military archives, his invention remained a subject of study. When World War II began, British engineers revisited his blueprints to develop new flame and smoke weapons for the Allied forces. The simplicity of his system, cheap, reliable, and easy to hide, was rediscovered in a new era of total war. The Livens Projector had outlived its creator's intentions. What began as a desperate invention in 1916 had become a template for mass destruction. When the Second World War erupted in 1939, the memory of William Howard Livens' invention resurfaced quietly among British ordnance officers. Many who had served in the Great War remembered the crude steel tubes that could unleash a wave of fire or smoke within seconds. This time, the design was no longer a secret. Engineers at Woolwich Arsenal studied the old schematics, realizing that Livens' core principle, mass fire through electrical coordination, was ideal for modern battlefield tactics. The technology evolved into new weapons: flame projectors, smoke generators, and even the early spigot mortars used by British commandos. The famous Hedgehog anti-submarine launcher, deployed by the Royal Navy, borrowed directly from the Livens concept. Multiple barrels, angled upward, fired simultaneously to saturate a target zone. It was Livens' legacy, reborn under a different name. Ironically, while his ideas powered Britain's war machine once again, Livens himself remained out of the spotlight. He had left the army years earlier, returning to quiet civilian life in Surrey. He spent much of the 1930s developing mechanical systems for agriculture and home utilities, devices that showed the same ingenuity, but none of the destruction. Yet, for all his new projects, the shadow of the Great War lingered. In the early 1940s, as new wars revived his designs, historians began to re-examine his role. Was Livens a hero of military innovation, or the engineer who made mass gas warfare possible? The answer was uncomfortable. His invention had saved Allied soldiers by giving them a fast, overwhelming method of retaliation, but it had also legitimized the industrialization of chemical warfare. The British government never officially condemned him, but they never celebrated him either. When questioned years later about his invention, Livens reportedly said, "It was never about death, it was about solving a problem. To him, the projector was an engineering challenge, not a moral one. The problem was how to deliver a large amount of gas quickly and accurately. The solution was a simple steel tube and an electric switch. Everything beyond that, politics, ethics, consequences, was outside his design brief." That rationalization defined Livens as much as his invention did. In many ways, he embodied the paradox of 20th century warfare: progress built on efficiency, innovation built on necessity. After the war, as the world turned against chemical weapons, Livens' name was nearly erased from official memory. In the 1925 Geneva Protocol, gas warfare was banned. The British government quietly decommissioned remaining Livens projectors and restricted public access to technical documents. What had once been a point of pride became an unspoken chapter of history. Yet his influence could not be undone. Military historians later noted that Livens' method of synchronized electrical firing directly inspired later systems such as multiple Kassad. Rocket launchers, flame units, and smoke curtain devices used throughout the mid-20th century. His principle, simplicity multiplied by scale, became a cornerstone of modern battlefield engineering. When engineers at the Ministry of Supply designed the Conga, a WWII flamethrower that fired liquid explosive through flexible hose, they cited Livens' early work as conceptual groundwork. Even in civilian industries, his approach to pressurized fluid projection shaped innovations in construction and mining. By the time of his death in 1964, William Howard Livens was a largely forgotten figure. Newspapers carried brief obituaries referring to him as a former Royal Engineers officer and inventor. Few mentioned his role in shaping modern warfare. Yet for military historians, his impact was undeniable. The Livens Projector had not only changed how gas was delivered, it had changed how wars were fought. It proved that massive coordinated weapons systems could be controlled by a single signal. That principle paved the way for everything from modern rocket batteries to missile salvos. In a sense, Livens had built the prototype for an era when machines would fight wars with synchronized precision, directed by electricity rather than men. Today, his invention survives only in fragments, rusted steel tubes unearthed in northern France, studied by archaeologists as relics of the First World War. Each discovery serves as a silent reminder of a time when one man's simple idea reshaped the battlefield. William Howard Livens never sought fame, and perhaps that was fitting. His greatest achievement was also his greatest burden. He proved that ingenuity could be both a gift and a curse, and that in war, the line between invention and destruction is thinner than the barrel of a steel tube buried in the mud.